Hello everybody. In this video, I'll be discussing the graphical method of voltage stability analysis. The topics of Unit 2 are listed below. Comparison of voltage and angular stability of the power system. Methods of voltage stability analysis. PV curve method of voltage stability analysis. And QV method of voltage stability analysis. In this video, I'll be discussing the first two topics, that is the difference between voltage and angular stability and the methods of voltage stability analysis. Let me recollect once again how the power system stability is classified. As you see here, power system stability is classified into three categories: rotor angle stability, frequency stability, voltage stability. Further, rotor angle stability can be classified into small disturbance rotor angle stability and transient stability. Further, it can be classified based on time frame as short term and long term. Whereas rotor angle stability, will come under short term stability. The second category is frequency stability. Based on time frame, frequency stability can be classified into short term and long term frequency stability. Voltage stability can also be classified into two categories based on the nature of the disturbance, which I discussed earlier: large disturbance voltage stability and small disturbance voltage stability. Also, based on the time frame, we can have two types, that is short term voltage stability and long term voltage stability. Now we will move on to the next topic, the comparison of voltage stability and rotor angle stability. First point is related to the definition, how voltage stability is defined and how rotor angle stability is defined. As I discussed earlier, voltage stability is concerned with the ability of power system to maintain acceptable voltages at all the system buses under normal conditions, as well as after being subjected to a disturbance. Whereas the rotor angle stability is the ability of the power system to remain in synchronism when subjected to a disturbance. The second point is, as the load is the driving factor for voltage stability, we generally call the voltage stability as load stability, whereas generator is the driving factor for the rotor angle stability. Therefore, it is called as generator stability. The third comparison is voltage stability is concerned with load areas and load characteristics. These are the influencing factor of voltage stability. Whereas rotor angle stability is concerned with integrating remote power plants to a large system over long transmission lines, as shown in figure. The next comparison is, if voltage collapses in load area, it's probably mainly a voltage instability problem. Whereas if voltage collapses at a point in a transmission system remote from loads, it's an angle instability problem. Here you have to note, here voltage stability is concerned with load area, whereas here voltage collapse occur in the transmission system which is remote from load area. The fifth point is, the voltage stability is affected by reactive power control. Also, rotor angle stability is also affected by reactive power control. It remains same. Next comparison is, transient voltage is closely associated with transient rotor angle stability, whereas longer term voltage stability is less interlinked with rotor angle stability. The last point is, voltage stability depends on the system to maintain equilibrium between the load demand and load supply. There should be a real power balance. There should be a balance between the supply and the demand. Rotor angle stability depends on the ability of each synchronous machine to maintain equilibrium between electromagnetic torque and mechanical torque. These are the points which gives us clear understanding about the comparison of voltage and rotor angle stability. Next, let me move on to the next topic, methods of voltage stability analysis. How do we classify voltage stability analysis? Methods. There are two methods. One is static voltage stability analysis method. Another one is dynamic method of voltage stability analysis. Depending on the stability phenomenon or phenomena under investigation, one or both of these techniques may be applied. The system dynamics influencing voltage stability is normally slow. So, the static methods are used to analyze various aspects of the problem. Therefore, several researchers adopt static method of voltage stability analysis when compared to dynamic method of voltage stability analysis. The static method of voltage stability analysis allows the examination of a wide range of system conditions. Moreover, it provides much insight into the nature of the problem and identifies the key contributing factors. These are all the important features of static method of voltage stability analysis. Further, the static voltage stability analysis for a given power system state involves the determination of how close the system is to voltage instability. In existing, different methods are used to analyze the steady state voltage stability. The most commonly used methods of steady state voltage stability analysis are as follows: singular value decomposition method of voltage stability analysis, model analysis, L&X, PV curve method, QV curve method, and continuation power flow method. These are all the examples of static method of voltage stability analysis. This method depends upon the power flow equations. Now let me discuss about dynamic method of voltage stability analysis. Dynamic methods are conducted in the time domain, solving the system's differential equations. The dynamic methods are considered more precise, but at the same time, they are more time consuming. They require high computational power and high degree of model accuracy. Static methods provide rougher results, which are, however, useful in acquiring valuable and comprehensive insights. To summarize, let me compare the static method of voltage stability analysis and dynamic method of voltage stability analysis. The first point to be noted is static method is easier method of voltage stability analysis, whereas dynamic method is complicated method of voltage stability analysis. Static method involves solving of algebraic equations, whereas dynamic method of voltage stability analysis involves solving of differential equations. The third point is static method of voltage stability analysis involves simplified method of voltage stability analysis, whereas dynamic method includes detailed method of voltage stability analysis. Regarding computational time, in static method of voltage stability analysis, the computational time is less, whereas dynamic method of voltage stability analysis is more time consuming. Therefore, static method of voltage stability analysis is more suitable for online applications or online monitoring or online assessment of voltage stability. But dynamic method of voltage stability analysis is not suitable for online voltage stability analysis due to high computational time. The last point to be noted is regarding accuracy, as static method of voltage stability analysis involves more approximate model, it is less accurate or less precise when compared to dynamic method of voltage stability analysis. Whereas dynamic method of voltage stability analysis is more precise as we are including detailed model for analysis. I hope you are able to understand how voltage stability is classified, what is the comparison of voltage stability and rotor angle stability, and how do we classify the methods of voltage stability analysis in this presentation. Thank you.